The top official at the United States Space Agency NASA has said the country plans to test a spacecraft engine powered with nuclear fission by 2027, an advancement seen as key to long-haul missions, including a manned journey to Mars. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. NASA will partner with the U.S. military's Defense Advanced Research Projects Agency to develop the nuclear thermal propulsion engine and launch it into space, NASA Administrator Bill Nelson said on Tuesday. The project has been named the Demonstration Rocket for Agile Cislunar Operations, or DRACO. With the help of this new technology, astronauts could journey to and from deep space faster than ever, a major capability to prepare for crewed missions to Mars, Nelson said in a statement. The announcement comes amid a new nuclear space race between the US, Russia, and China, with the three superpowers working to expand their extraterrestrial nuclear capabilities, including for use propelling spacecraft and powering colonies on the Moon. A nuclear thermal rocket engine uses a fission reactor to generate extremely high temperatures. The heat is then transferred to a liquid propellant, which is expanded and exhausted through a nozzle to propel the spacecraft, according to NASA. A nuclear thermal rocket can be 3 or more times more efficient than conventional chemical propulsion, according to the agency. That means that a spacecraft powered by nuclear fission could result in faster travel times and less risk to astronauts. The technology could also allow for more power for instruments and communications on board. The U.S. has long used energy produced by radioactive material in its space work by harnessing the heat generated by its decay, according to the World Nuclear Association Industry Group. The country, however, has not used nuclear fission, which creates energy from splitting atomic nuclei, on spacecraft due in part to the challenge of managing the extreme heat created by the process. Nuclear technology has long played a vital role in prominent space missions, Mikhail Chudakhov, the IAEA's Deputy Director General and head of its Department of Nuclear Energy, said in February 2022. But future missions could rely on nuclear-powered systems for a much broader spectrum of applications. Our pathway to the stars runs through the atom. Under the NASA-DARPA agreement, NASA's Space Technology Mission Directorate will lead technical development of the nuclear thermal engine, which will eventually be integrated with an experimental spacecraft created by the military. The agency said the last U.S. nuclear thermal rocket engine tests were discontinued in the 1970s. In a statement, Stephanie Tompkins, the director of DARPA, hailed the plans to develop the Leap Ahead Advance. The space domain is critical to modern commerce, scientific discovery, and national security, she said. NASA and the Defense Advanced Research Projects Agency, DARPA, announced Tuesday a collaboration to demonstrate a nuclear thermal rocket engine in space, an enabling capability for NASA crewed missions to Mars. NASA and DARPA will partner on the Demonstration Rocket for Agile Cislunar Operations, or DRACO, program. The non-reimbursable agreement, designed to benefit both agencies, outlines roles, responsibilities, and processes aimed at speeding up development efforts. NASA will work with our long-term partner, DARPA, to develop and demonstrate advanced nuclear thermal propulsion technology as soon as 2027. With the help of this new technology, astronauts could journey to and from deep space faster than ever, a major capability to prepare for crewed missions to Mars, said NASA Administrator Bill Nelson. Congratulations to both NASA and DARPA on this exciting investment as we ignite the future together. Using a nuclear thermal rocket allows for faster transit time, reducing risk for astronauts. Reducing transit time is a key component for human missions to Mars, as longer trips require more supplies and more robust systems. Maturing faster, more efficient transportation technology will help NASA meet its Moon to Mars objectives. Other benefits to space travel include increased science payload capacity and higher power for instrumentation and communication. In a nuclear thermal rocket engine, a fission reactor is used to generate extremely high temperatures. The engine transfers the heat produced by the reactor to a liquid propellant, which is expanded and exhausted through a nozzle to propel the spacecraft. Nuclear thermal rockets can be 3 or more times more efficient than conventional chemical propulsion. NASA has a long history of collaborating with DARPA on projects that enable our respective missions, such as in-space servicing, said NASA Deputy Administrator Pam Melroy. Expanding our partnership to nuclear propulsion will help drive forward NASA's goal to send humans to Mars. Under the agreement, NASA's Space Technology Mission Directorate, STMD, will lead technical development of the nuclear thermal engine to be integrated with DARPA's experimental spacecraft. DARPA is acting as the contracting authority for the development of the entire stage and the engine, which includes the reactor. DARPA will lead the overall program, including rocket systems integration and procurement, approvals, scheduling, and security, cover safety and liability, and ensure overall assembly and integration of the engine with the spacecraft. Over the course of the development, NASA and DARPA will collaborate on assembly of the engine before the in-space demonstration as early as 2027. DARPA and NASA have a long history of fruitful collaboration in advancing technologies for our respective goals, from the Saturn V rocket that took humans to the Moon for the first time to robotic servicing and refueling of satellites, said Dr. Stephanie Tompkins, Director, DARPA. The space domain is critical to modern commerce, scientific discovery, and national security. The ability to accomplish leap-ahead advances in space technology through the Draco nuclear thermal rocket program will be essential for more efficiently and quickly transporting material to the Moon and eventually, people to Mars. The last nuclear thermal rocket engine tests conducted by the United States occurred more than 50 years ago under NASA's nuclear engine for rocket vehicle application and rover projects. With this collaboration, we will leverage our expertise gained from many previous space nuclear power and propulsion projects, said Jim Reuter, Associate Administrator for STMD. Recent aerospace materials and engineering advancements are enabling a new era for space nuclear technology, and this flight demonstration will be a major achievement toward establishing a space transportation capability for an Earth-Moon economy. NASA, the Department of Energy, DOE, and industry are also developing advanced space nuclear technologies for multiple initiatives to harness power for space exploration. Through NASA's Fission Surface Power Project, DOE awarded 3 commercial design efforts to develop nuclear power plant concepts that could be used on the surface of the Moon and, later, Mars. NASA and